So today we're going to cover day 2 of section 6. And today we're going to solve radical equations. Now, one thing before I do this. Okay, so today, again, we're going to cover 1.6b. And we're going to learn how to solve radical equations. These are the steps. Your first step is always going to be to isolate the square root. And then once it's isolated, then we're going to square both sides of the equation to cancel out that radical. And then from there, we'll solve. When we're solving these radical equations, you must check all answers. So let's go ahead and see our first example. So if you had it already opened up, actually that one wasn't too bad in the notes. All right. So step number 1 is to isolate the radical. So what I need to do is I need to move this x to the other side or move the radical. Actually, I'm going to move the radical so that way it's positive. So I'm actually going to add this whole thing, the square root of 15 minus 2x, and I'm going to move it to the other side by adding it. And now I have x equals 15 minus 2x underneath the square root. Step number 2, square both sides. By squaring this radical, it cancels it. So what I'm doing is squaring this, it makes the radical disappear, and now I'm left with x squared is equal to 15 minus 2x. And now I can solve this. I need to get it into standard form, and then it's going to turn into something that I can factor. So I'm going to add the 2x. X squared plus 2x equals 15. Move the 15. X squared plus 2x minus 15 equals 0. I now have a trinomial that I can solve. Now, I can also, technically, I can solve this by factoring, completing the square, quadratic formula. Again, factoring is going to be the fastest way. So now I'm going to go ahead and come over here to the side because I ran out of room. I'll go ahead and do it up here. So now I'm going to just rewrite this. I need to find the factors of negative 15 that when I combine them, I get a positive 2. And those factors are going to be positive 5 and negative 3. I now need to set each of my factors equal to 0. Solve for x. First one I subtract 5. So my first solution is x equals negative 5. My next one is x equals positive 3. Now, for all of these radical equations, we must check. So I need to take these two answers I just got, and I need to plug them back in to the original. So I'm going to come over here to do the check. Come over to the side. So this is my check now. So I'm going to first plug in x minus 15 minus 2x equals 0. I'm going to plug in the negative 5 first. Negative 5 minus, and I'm going to simplify what's under the radical. This becomes 25. Square root of 25 is 5. And negative 5 minus 5 is negative 10. Negative 10 does not equal 0. So this answer is out of here. So this one doesn't work. Now, don't automatically assume that because the first one didn't work, the second one will. You could find that they both work. Neither of them work. So you always have to check everything. So now I got to do the check on the next one as well. So I'm going to plug in, and I get 3 minus 15 times 2 times 3. And I want to see if it equals 0. Minus 6. 15 minus 6 is 9. Square root of 9 is 3. 3 minus 3 is 0. So 0 equals 0. X equals 3 is the correct answer. So that one checked out. So you have to check. Now, my advice to you is when we take this test, because you are going to do a lot of checking, I would just go through and solve everything first. And then after you've got all your answers, go back and check. Chances are we'll take off minimal points if you don't do the check. You're better off solving everything. And then if you don't check for extraneous solutions, it might be only a point or two that we'll take off. But as we get closer to that test, I will tell you how much the check might be worth. So my advice to you is solve everything and then go back and do the checks. Just in case you're slow and you may not get to all the questions, I would definitely solve everything first, then go back and check to see which ones to throw away. Okay, the next one, number 2. Same thing. We need to isolate the radical first. So I'm going to go ahead and add 3x plus 18, the square root of that, to both sides. And now I'm left with x equals the square root of 3x plus 18. Again, I got to square both sides. Squaring the radical makes it just come on out. So now I'm left with x squared equals 3x plus 18. I need to move the 3x and the 18 to the other side. And I get 3x minus x squared minus 3x minus 18 equals 0. So what I did was I subtracted both of these and moved them over here. And now I got to factor this thing. It is factorable. Factors of negative 18 that give me negative 3 are going to be x minus 6 and x plus 3. Set each of the factors equal to 0. Add 6. First solution is x equals 6. Subtract the 3. And x equals negative 3. Again, I got to do the check. So I'm going to plug them both in. So I'm going to do the positive 6 first. So 6 minus 3 times 6 plus 18 equals 0. 6 minus 18 plus 18. 6 minus the square root of 36, which is 6. 6 minus 6 is 0. That one checks. So x equals 6. This one's a good answer so far. And now let's plug in the next one. 6 and then 3, not 6, sorry, that's a negative 3. Negative 3 minus 3 times negative 3 plus 18. That's all under the radical. Negative 3 minus negative 9 plus 18. Negative 3 minus 9, square root of 9. Negative 3 minus 3 gives me negative 6. This is not a true statement, so this is extraneous. Get rid of that one. Try the next one. Again, first step is to isolate the radical. This one's already isolated for me. So what I'm going to be doing is squaring both sides. So here, 4x plus 13 equals 2x minus 1. When I square the left side, the radical just disappears. However, the right side, I got to FOIL that thing. Do not just distribute the 2 to both of these. Remember, you're writing this 2 times and FOILing it. Either that or memorize the pattern for the binomial squared. So this turns into 4x squared minus 4x plus 1. I now need to get this thing in standard form so I can factor it. I'm going to keep my x squared term positive, so I'm going to move the 4x and the 13 over here. So now I have 0 equals 4x squared minus 8x minus 12. I now need to always look for a GCF first. before you try to start factoring that. All right, so for the next one, I'm going to factor out a GCF first. X squared minus 2x minus 3. Now, do not forget about your GCFs, because in the end, we need to set them equal to 0. However, when your GCF is just a constant, it's not going to help us. But if that were a 4x, I would get one of my answers to be x equals 0. So now I need to factor this. Factors a -3 that when I combine them give me -2. And that's going to be x minus 3 and x plus 1. Set each one of my factors equal to 0. Now, even the GCF here, but notice this is nonsense. So because there was no variable to solve for, I really didn't need to do that one. But just to show you, you always have to still remember that that GCF could be a potential solution. Now set each one equal to 0. Add 3. X equals 3. Subtract 1. X equals -1. I now need to do the check. I need to plug both of these in. So do two different problems. So my problem was 4x plus 13. So 4 times 3 plus 13 under the radical. I'm checking the first one first. And then minus 1. 12 plus 13. 6 minus 1. 12 plus 13 is 25. Square root of 25 is 5. That one works. So this is a good answer. Let's try the next one. 4 times -1 plus 13 equals 2 times -1 minus 1. -4 plus 13. -2 minus 1. Square root of 9. Square root of 9 is 3. This is not a true statement, so the only correct answer is going to be x equals 3. So get rid of that one. Let's try number 4. Again, first step, isolate the radical first. So I need to add the 1 to both sides. So now I'm left with the square root of 6x plus 7 is equal to x plus 2. Next step, square both sides. Again, I got to FOIL this thing. Do not just distribute that exponent. So the left side, this just comes out of the radical, but the right side, I got to FOIL it, and it turns into x squared plus 4x plus 4. Again, I like to keep my x squared term positive, so I'm going to subtract the 6x and the 7. So now my trinomial I'm going to factor is x squared minus 2x minus 3. And notice it's the same one that I just did in example 3. Same trinomial. Just a coincidence. X minus 3, x plus 1. Set each one equal to 0. Add 3. X equals 3. Subtract 1. X equals -1. All right, so now I got to check. So let's plug them in. So 6 times 3 plus 7 under the radical minus 1 equals 3 plus 1. So 18 plus 7, 25. 25, square root of 25 is 5. 4 equals 4. This one checks. So this is a good answer. Now let's check the -1. 6 times -1 plus 7 minus 1 equals negative 1 plus 1. So negative 6 plus 7, negative 1 plus 1 is 0. Negative 6 plus 7 is 1. The square root of 1 is 1. 1 minus 1 is 0. This is good. Now you might have noticed, like the first couple problems, most of the negatives weren't working, but here we go. You can't rely on that because negative 1 worked on this one. So you have to check everything. Okay, don't take for granted that, automatically all negatives don't work. Sometimes they do. All right, next one. We're actually going to have to isolate the radical twice here. So this one's a little bit more challenging. So let's try example 5. So again, my first step is to isolate the radical. This one actually has 2 radicals, so I'm going to have to do that isolation process twice. So watch what we're going to do. We're going to isolate one of them. So I'm going to move this one to the other side. So now I'm left with 2x plus 3 is equal to x, let's see, let's just do it as 1. Doesn't matter the order. All right, so now I've isolated one of them. So I'm going to square both sides. Process is still the same. And again, this right side, I got to FOIL this crazy thing. So let me write it up at the top just to show you how I'm going to do this right side. So it's 1 plus the square root of x plus 1 times the same thing again. So I'm FOILing. So when I FOIL this, 1 times 1 is 1. And then plus 1 square root of x plus 1 plus 1 square root of x plus 1 plus, and then anytime you multiply a radical by itself, the radical just disappears. So now I can combine the middles. This gives me 2 times the square root of x plus 1. And then I still have this guy at the end. I can also combine this 1 and this 1. So then this thing finally simplifies down to 2 times x plus 1 under the radical plus x plus 2. So that's what I got when I square this thing. This one, it just cancels it. So 2x plus 1 plus x plus 2. All right, now I still got a radical here. So now I'm going to isolate this radical. So what I'm going to do is move the x and the 2 to the other side. So I can subtract this x, subtract this 2. Subtract x, subtract 2. So now I'm left with x plus 1 is equal to 2 times the square root of x plus 1. Now, I don't want to have to try to work with the fraction, so I'm just going to leave that number in front of that radical when I square both sides. So now I'm going to square both sides. Again, I'm FOILing that left side. I'm writing x plus 1 twice. This will turn into x squared plus 2x plus 1. And then this 2 now, because there's no plus or minus sign here, I square the 2. And then squaring this makes it come out. And now I need to distribute this. I'm going to rewrite the left side. And now I need to get my like terms together so I can get this trinomial where it's factorable. So what I'm going to be doing here is moving the 4x over as well as the 4. So I'm left with x squared minus 2x minus 3 equals 0. I now can factor it. X minus 3, x plus 1. Set each of my factors equal to 0. Add 3. First answer is x equals 3. Next answer is x equals -1. Again, we got to check it. So let's plug it in. So here's my check. So I'm going to plug in 3 first. So 2 times 3 plus 3, that's under a radical, minus 3 plus 1 under a radical equals 1. So 6 plus 3, 3 plus 1, 9. Square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1. 1 equals 1. That one works. So this is a good answer. And now let's plug in the -1. So again, my original problem was 2 times -1 plus 3 under the radical minus -1 plus 1 under the radical equals 1. -2 plus 3. -1 plus 1 is just 0. Square root of 0 is just 0. So then this becomes a 1. Square root of 1 is 1. 1 equals 1. It checks. This is a good answer as well. They both checked. Again, step number 1, isolate the radical. Again, we're going to have 2 radicals. We're going to have to do this squaring technique twice. So let's move this one to the other side. So 2x minus 5 equals 1 plus x minus 3 under the radical. Again, I got to square both sides. Square this one, square this one. This one, it just cancels. This one, I'm doing that same thing again. I'm going to do x minus 3, 1 plus x minus 3. And again, I'll FOIL it. Once I FOIL this, 1 x minus 3 plus 1 x minus 3, and then x minus 3 just comes out. Add those two together, and then I can also add the 1 and the -3. So then this will actually simplify down into 2 square root x minus 3 plus x minus 2. So let me write that in here. So 2 x minus 3 plus x minus 2. Again, I need to isolate this radical. So I'm going to move this over and this over. So now I'm left with x minus 3 equals 2 times the square root of x minus 3. I'm squaring both sides. So the x minus 3 squared is going to turn into x squared minus 6x plus 9. This side becomes square the 2, and then the radical just disappears when you square that. I'm going to distribute. Rewrite this left side. And now I'm going to move my like terms together. So I can move the 4x and move the 12. So now I'm left with x squared minus 10x plus 21 equals 0. Factors of 21, positive 21, that will give me a -10. And that's going to be a -3 and a -7. Set each of the factors equal to 0. X minus 3 equals 0. X minus 7 equals 0. Add 3. First answer is x equals 3. Next answer is x equals 7. I got to do the check. So again, my original equation, I'll plug in 3 first. So 2 times 3 minus 5 minus 3 minus 3 equals 1. 6 minus 5 3 minus 3 is 0. 6 minus 5 is 1. Square root of 0 is 0. 1 minus 0 is 1. So 1 equals 1. That one works. So good answer here. And now plug in 7 as well. So 2 times 7 minus 5 minus 7 minus 3 equals 1. 14 minus 5. 4. 14 minus 5 is 9. Square root of 4 is 2. Square root of 9 is 3. 3 minus 2 is 1. 1 equals 1. This one checks as well. So we're good there. All right, here is number 7. Again, isolate the radical. Well, it's already isolated. So let me just square both sides. Again, remember, we got to FOIL this thing. So this will end up, once I FOIL it, becomes x plus 5. That comes out of the radical, minus 4 times x plus 5 plus 4 equals, and this just came out. Again, I want to isolate my next radical. So I'm going to move the x over. Move the x, move the 5, move the 4. So minus x, minus 5, minus 4. Once I do all of that, I end up getting negative 4, x plus 5, and then over here, notice the x is canceled, and now I'm just adding negative 1, negative 5, negative 4, and I get negative 10. So again, what I'm going to do here is go ahead and square both sides. And what I can do is divide both of these by negative 1, and really what I'm squaring is this. So this becomes 16 times x plus 5 equals 100. And now I can begin, I got to distribute. So I get 16x plus 80 equals 100. Move the 80. 16x equals 20. Divide by 16. I'm going to reduce 20 over 16, and it reduces to 5 over 4. Again, I got to do the check. So I'm plugging in 5 over 4 plus 5 under the radical minus 2 equals 5 over 4 minus 1. So here, 5 over 4, I need to get a common denominator. I'm going to change the 5 into 20 over 4. Same thing here, 5 over 4, change the whole number 1 into 4 over 4. 25 over 4, it's under the radical. This becomes 1 over 4. This becomes, when I square root it, 5 over 2. And this becomes 1/2. And then I can find a common denominator here. This will become 4 over 2. 5 over 4 minus 5 over 2 minus 4 over 2 is 1/2. 1/2 equals 1/2. So 5/4 is a good answer. Last one on this slide. Again, isolate the radical. One of them's already isolated. Square both sides. This comes out. The right side needs to be FOILed. Once I FOIL it, it's x minus 1 plus 4 times x minus 1 plus 4. So again, I could group my like terms here and get x plus 3 plus 4x minus 1. I need to move the x to the other side and the 3 because I want to isolate the radical again. So now I'm left with 3x minus 2 equals 4 times x minus 1. I'm going to square both sides to get rid of the radical. I got to FOIL the left. So this ends up being 9x squared minus 12x plus 4 equals 16 times x minus 1. I'm going to distribute 16x minus 16. Move the 16x and the positive 16. Move those both to the other side. So I'm subtracting the 16x and adding the 16. And now the trinomial I'm going to factor is 9x squared minus 28x plus 20 equals 0. I'm just going to guess and test here. Factors of 9, I'm going to use 9 and 1. And factors of 20, 10 and 2. And negative, negative. Set each of the factors equal to 0. Add 10. 9x equals 10. Divide by 9. And x equals 10 over 9. Add 2, and x equals positive 2. Again, we got to check. So let me plug them in. 4 times 10 over 9 plus 1, that's under a radical, equals 10 over 9 minus 1 plus 2. So then when I multiply this, I get 40 over 9. I'm going to change the 1 into 9 over 9. Same thing here. Change the 1 over into 9 over 9. This becomes 49 over 9. This becomes 1 over 9. And this should be an equal sign. Plus 2. Square root of 49 is 7. Square root of 9 is 3. And then here, square root of 1, 3 plus 2. This becomes 2 and 1/3. If I go ahead and make this into a mixed number, 2 and 1/3. So that one checks. You could have also left it improper, found a common denominator here, either way. And then I'm also going to plug in 2 to make sure that that answer works. So this one's good. So when I plug in 2, 4 times 2 plus 1 equals 2 minus 1 plus 2. 8 plus 1. 2 minus 1 is 1. 9. Square root of 1 is 1. Square root of 9 is 3. 1 plus 2 is 3. This one checks as well. So both answers are good. That is it for this slide. All right, so the next part is if it's any other root other than a square root, we're just going to raise it to the same power as the index. So the square root, we squared it to cancel it. If it's a cube root, we're going to raise it to the third power. If it's a fraction exponent, we're going to raise it to the reciprocal power. So let's take a look. The first example we're going to do is a cube root. So the steps are still the same. I need to isolate the radical. Yes. Move this radical, this cube root, to the other side. So then I'm left with 4x squared minus 4x plus 1. And this is a cube root. So now to cancel the cube root, what I'm doing is cubing both sides. So raise it to the third power. But on this problem, it's just canceling the radical from both sides. So I canceled it. So now all this comes out. So 4x squared minus 4x plus 1 equals x. I need to set it equal to 0. So I'm going to move the x to the other side. 4x squared minus 5x plus 1 equals 0. I need to factor this thing. Now, I can do factor by grouping, or I can do guess and test. I think guessing and testing is pretty easy because the factors of 1 are just 1 and 1. Factors of 4 are either going to be 1 and 4 or 2 and 2. So if I guess, I'm going to put a 4x and an x, and then my factors of 1 are 1 and 1. And notice it's a positive 1. So this tells me the signs have to be the same, and they're both going to have the sign in the middle. Now, I need to double check this and FOIL it to make sure it's not 2 and 2. So if I do a quick FOIL here and just check outer and inner, I get negative 4x. Inside gives me negative x. And when I add them, it's the negative 5x. So I did guess and test well. You can also do grouping here. Again, whatever you're comfortable doing. So now again, set each one equal to 0. Add the 1. 4x equals 1. Divide by 4. And the first answer is x equals 1/4. This one I'm going to add 1. X equals positive 1. I still have to check. So let me plug them in. I'll do the 1/4 first. So I get 4 times 1/4 squared minus 4 times 1/4 plus 1 minus 1/4, the cube root of it, equals 0. And this is all under a cube root as well. So let me simplify what's under the radicals. So this becomes 1/4 squared is 1/16. And then when I times that by 4, it's 4/16, which simplifies to 1/4. This just becomes a 1, and then plus 1, minus the cube root of 1/4 equals 0. Now, you might start thinking, oh my gosh, what am I going to do? How am I going to find a cube root of 1/4 without a calculator? But see what happens here. The 1's cancel, so we're really just doing the cube root of 1/4 minus the cube root of 1/4. Anything subtracted by itself is 0. 0 equals 0, it checks. So you're not actually trying to figure out what the cube root of 1/4 is. You're just going to realize that it's going to cancel out. Okay, let's try the next one as well. We got to plug in the 1. So 4 times 1 squared minus 4 times 1 plus 1, all under the cubed root. And then the cube root of 1 equals 0. So 1 squared is 1, times 4 is 4, minus 4 plus 1. Same scenario. The 4's cancel, so I'm doing the cube root of 1 minus the cube root of 1. The cube root of 1 is just 1. 1 minus 1 is 0. But again, same idea here. If you're subtracting the same radical by the same radical, it's going to cancel and become a 0. So this one checks as well. So 2 solutions, and they both work. Now we have a question where it's raised to a rational exponent. But remember, this rational exponent on number 10, this is really just saying the cubed root. So again, instead of turning it into a cube root, I'm just going to raise each side or each power to its reciprocal. But again, we need to first isolate it. So I need to move this one to the other side. So I'm going to add it to both sides. So 3x plus 7 raised to the 1/3 power equals 4x plus 2 raised to the 1/3 power. So in order to get rid of that rational exponent, I'm going to multiply or raise both sides to the reciprocal power. So 3 over 1, 3 over 1. This just cancels to an exponent of 1. So then this is left with just 3x plus 7 equals 4x plus 2. Move my like terms together. Doesn't matter which way you move it. I get negative x plus 7 equals 2. Subtract 7. Negative x equals negative 5. I don't want a negative variable, so divide by negative 1. And x equals positive 5. I now need to plug it back in to make sure it works. So 3 times 5 plus 7 raised to the 1/3 power minus 4 times 5 plus 2 raised to the 1/3 power. And I want to see if it equals 0. So 15 plus 7 raised to the 1/3. 20 plus 2 raised to the 1/3, 22 raised to the 1/3 minus 22 raised to the 1/3. We don't need to worry about figuring out what the cube root of 22 is because anything subtracted by itself is 0. 0 equals 0. This is a good answer. It checked. So here we're taking the 4th root, but again, the process is the same. Instead of squaring both sides to cancel it, I've got to raise both sides to the 4th power. So this one will be to the 4th, this one to the 4th. This one just cancels it. So then I'm left with x squared plus 6x, 2 to the 4th power, 2 times 2, 4, times 2, 8, times 2 again, 16. I need to get this into a solvable form. So I'm going to make it a trinomial. Factors of negative 16, that when I combine them give me positive 6, and that's going to be positive 8 and negative 2. Set each of the factors equal to 0. Subtract 8. X equals negative 8. X equals positive 2. So again, I got to check it. See if they both work or if one works or if neither works. So again, it's the 4th root. So if I see that. So it's going to be negative 8 squared plus 6 times negative 8 equals 2. And this is all under a 4th root. 64 minus 48. 64 minus 48 is 16. The 4th root of 16 is 2. 2 equals 2, it checks. So this is a good answer. And now let's plug in 2. So again, if I do 2 squared plus 6 times 2 equals 2. 4 plus 12. 4 plus 12 is 16. 4th root of 16 is 2. This one checks as well. So 2 answers, negative 8 and positive 2. Next one, same thing. It's a 4th root, even though it's not written under a radical. Remember, whenever you have a rational exponent, it's really like finding the root. So we're really doing the 4th root here. So again, same process. Instead of putting it under a radical, just raise both sides to the reciprocal power. Reciprocal of 1/4 is 4/1. So this just cancels. This comes out. I actually have to figure out 4 to the 4th power, and that's 256. I'm going to move the 256 over. 3x squared plus 52x minus 256. I now need to factor this thing. There is no GCF because 3 won't divide into those. So I can either do grouping or guess and test. Factors of 3 are just 3 and 1. Factors of 256. Okay, so factors of 256, just to save time here, it's going to be 64, positive 64 times negative 4. Again, I would have probably done grouping on this one. This one was kind of large. Or you could guess and test. So now set each factor equal to 0. Move the 64. 3x equals negative 64. Divide by 3. And x equals negative 64/3. Add the 4. X equals 4. I now need to do the check. So this negative 64 might be fun. over 3. So 3 times negative 64 over 3 squared plus 52 times negative 64 over 3. And all of this is raised to the 1/4 power. So let's see what we get. So once I square this thing, I end up getting 3 times 4,096 over 9. Here I can I'll multiply 52 times negative 64, and this gives me 328 over 3 negative equals 4. Now I got to multiply this. This will actually simplify. I can make that a 3. So now I got a nice common denominator here. So when I combine these, I get 768 over 3. And also remember, this is still all to the 1/4 power. So I divide this. This becomes 256 raised to the 1/4 power. 256, the 4th root of that is actually 4, because I did that over here, remember? So 4 equals 4. This answer actually checks. This is good. Now I got to plug in the 4. So again, 3 times 4 squared plus 52 times 4, all of that raised to the 1/4 power, and I want to see if it equals 4. So 3 times 16, 52 times 4 is 1,000, now let's see, 52, 208, I think. 208. 3 times 16 is 48. When I add that, again, I get 256. And again, the 4th root of 256 is 4. This one checks as well. So the two answers, both of them work. The next two examples are the same thing. I'm going to be raising them to the reciprocal power. Now, notice this one, it's a little different. What I want to do is get rid of one of these first. Let me rewrite this one. I'm going to be raising both sides to the 5/1 power. So then this will cancel, this will cancel. So this becomes x minus 3 squared, and this one's just gone. I got to FOIL this. X squared minus 6x plus 9 equals 4x. Move the 4x. X squared minus 10x plus 9 equals 0. Factors are going to be x minus 9, x minus 1. Set each of the factors equal to 0. Add 9. X equals 9. Add 1. X equals 1. Plug them in and check. They both work. Let me see if I can get to the last one. So these will both check. I'll do the check in the video. And then here, same thing. We need to get rid of the exponent. So I'm going to raise both sides to the 4th power. This will simplify. This becomes an x squared. This will simplify, and it's 3x cubed. So I'm going to cube it. So then this becomes, I need to put the power on everything, not only just this. So this is actually going to become 3 to the 4th. All right, so don't forget that this power of 4, it canceled the fraction, but it also needs to still go on the 3. So 3 to the 4th is 81. And then this will become x cubed. So actually, what I could have done is get rid of the parentheses. And then equals x squared. I need to move this over. And I get 81x cubed minus x squared equals 0. I'm going to factor out a GCF. So I'm going to factor out an x squared. And then I'm left with 81x minus 1 equals 0. Set each of the factors, including the GCF, equal to 0. This gives me x equals 0. Add 1. 81x equals 1. Divide both sides by 81. And x equals 1 over 81. Again, I need to check. They're both going to work, but let me show you the check. So here, my check. Plugging in the 0. 3 times 0 raised to the 3/4 equals 0 to the 1/2. Well, anything times 0 here is 0. 0 equals 0. It checks. And then now I'll plug in the 1 over 81. So what I'm doing here is I need to figure out what the 4th root, because remember this is the root and this is the exponent. So the 4th root of 1 over 81 is 1/3. And then the square root of 1 over 81 is 1/9. And then here this becomes 1 over 27. And then when I multiply this, I get 1/9. 1/9 equals 1/9. So again, both answers are good. So I have x equals 0 and x equals 1 over 81. Now I know I said I would go back and do the check on number 13 as well. So let me just check and do the check for x equals 9 and x equals 1. So I'll go ahead and plug them in. So 9 minus 3 raised to the 2/5 is equal to 4 times 9 raised to the 1/5. And I get 6 raised to the 2/5 power. And then 36 raised to the 1/5 power. And then here what I can do is square the 6 first, because remember that's the exponent, and then the 1/5 is left, and now the two sides are equal. So I don't need to worry about simplifying, just make sure that the two sides end up simplifying to the same thing. I can also plug in the 1, so I get 1 minus 3 raised to the 2/5 is equal to 4 times 1 raised to the 1/5. So negative 2 raised to the 2/5 power equals 4 raised to the 1/5. Again, apply the power first, turns into a 4, and then the 1/5 remains. And again, you have the same thing equals the same thing. So again, both answers here are good. So you have your WebAssign homework that's due on Monday, as well as your quiz. Remember to make your video for completing the square. Have a good weekend.